We'll start with the entrance of the system. So the biggest coordination part of the electrical distribution system is selecting a voltage that applies to the building, to the site of where the construction is going to take place. Through the inception of the project, you have to analyze the building, whether you do it in a medical office building, a residential, a complex, or however it is that you're going to feed the building. The voltage is directly related to the HVAC systems, the lighting type lighting systems, and the plumbing systems of the building. These three voltages are the three most common voltages: 13.8 kV, 480, 277, and 122.08. They have different applications. 1380 is mainly used for larger buildings, primary services. 480 is used in the most common application is in office buildings, medical office buildings, hospitals. And the 208 120s are used in the residential buildings, residential mid-rises, and small to mid-sized office buildings. The 208s are not very commonly used when you're using chillers, when you're using large pumping systems, large horsepowers. Those are more used towards the 480 volt side. The other part of the system selective is the geographical location of the building. So once you select a building, where it is located, whether it be in the city of Boston, in a rural area, in a town, each area has a distribution system. For example, in the city of Boston, there's a 13.8 distribution underground. So every building is going to have a 13.8 input, a utility transformer, and then you can select the output voltage to that.
Well, the transformer is used to change the voltage from the incoming, which is called the primary side of the transformer, which is the higher voltage, and then through the windings of the transformer, the coil, it's reduced down to a usable voltage that you're trying to utilize for the building. So the transformer is, just think of it as, you know, the high voltage in and the low voltage out, and that happens not only on the electrical service side, but it also happens numerous times within the building when you're trying to transform voltage in the building from, say, as Will said, a commercial building or a building with a large mechanical load. You know, a lot of those feeds would be 480 volts. There's a picture of a pad-mounted transformer situation. So this particular one was fed underground. So it may have risen from a pole, and then the primary feeds the transformer, and then the transformer feeds the building. The pole-mounted transformer, this you've seen numerous times, I'm sure. In some cases where either there's not the available real estate to put a pad-mounted transformer, and you know, in the city of Boston, sometimes that's not available. So the utility company mounts the transformers on a pole, and then your primary would rise, or the secondary rises up the pole, picks up the feed from the transformers, and that's the service entrance into the building.
So what he's asking is the installation of a vault. The installation of vaults, of underground vaults, are tricky because you're not coordinating with the interior of a building or moving around offices or moving around units. You actually have to submerge it's actually a 20 foot by 10 foot by 13 foot deep box being submerged underground. So it has to be coordinated with civil, has to be coordinated with water lines, it has to be coordinated with existing 13.8 lines within the city of Boston or the exterior parts. So this, usually NSTAR will take about 6 weeks to re-engineer anything that's going to go into the sidewalks, because those sidewalks are full of water lines, steam lines, 13/8 line. So before we can drop up, I'm actually working on a job right now in New York Street where we're actually submerging one of these things, and it is a hassle to try to coordinate with the building, and then you have to coordinate the inverts into the building. That particular service has something called a current limiting cabinet. I don't know if you're familiar with that, but basically all that means is that it limits the current coming from the transformer. So those two are the most common services that the city of Boston has. The in-grounds are the most common nowadays. The exterior ones were more common back in the 90s and 80s. We're running out of room, so they're not really putting one of them. So, any other questions on the vaults? No? Okay.
From a practical point of view, as a contractor, as a general contractor, the things you have to be aware of is the process of getting a service approved. You know, we'll probably touch on the fact that he puts together the required loads for a building. He makes an application to the utility company and gives them the loads of the different components of the building, and then makes a request for the size service or the size transformer, and we'll talk about that. But from a practical point of view, the utility company will come back and say, yeah, you need this, but we're only going to give you that. And the other thing is when you're dealing with the utility company with either underground distribution like the primary conduits to a transformer, you know, your electrical contractor, you have your civil guy do the excavation, the electrical contractor will put in the conduit. Before anything can be covered, not only do you need an electrical inspector's approval, but you also need the utility company's approval. They want to make sure that that duct bank is correct, that it's got the proper structure that's needed, it's got the proper grounding that's needed, and the utility company has several different inspectors that you'll have to deal with. So you have an underground inspector that'll look at the conduit. If you're taking the feed from overhead, you got an overhead line supervisor that has to approve any work that's being done. And when you get into the vault, you have inspector that will look at the vault structure. You have then, when the vault is prepared interior in the building, there's a grounding network. There's a whole set of specifications that have to be complied with. But every step of the way, NSTAR comes out. They have if you're pulling conductors underground to the building, they have an underground inspectors for the underground wires. So you're dealing with 6 or 7 different entities within the utility company, which you have to comply with. So nothing happens quickly. So you just have to be aware of that with your timing, and you know your schedule on the job is when you need service. Couple of different, you know, the different types of services. I just alluded to your permanent service and the load letter that Will can talk about. The service coordination with in the electrical design. Temporary service is, you know, on a particular building, like a high-rising building. We're doing several of those right now. The temporary service on a typical high-rise building could be 3,000 amps. And it's usually at 480 volts. The tower cranes that you see all over the city, their feed is a 400 amp feed at 480 volts. Now we're doing a project right now in Seaport where there are 3 tower cranes on the site. Then they have the requirements for welding on the site, which is usually a 480 volt, 100 amp feed. You have the staging that you see traveling up and down the building, and that's usually 100 amp feed, 60 amp feed, depending on what they have. So, you know, they eat up. Then you have, once you get the building out of the ground, you have the temporary lighting and power and so on throughout each floor. So it's a sizable service that's required, and it's, you know, it's a very intricate coordination with the utility company to get what you need when you need it.
So the timing of a service, like he says, is very important. So during this inception of the design is when the engineer has to start understanding what he's going to put in a building. That has to be translated to the utility company. So much like we size our service, the switchboard that you see in E201, there's a switchboard that you see, that has to be sized for the loads of the building. What we provide to the utility company is a site plan that you see in E002. We provide them a riser that you see in E201. And that tells them how the building will operate. And we do that in conjunction with something called a load letter. A load letter tells them how much capacity is being drawn from their transformers or from their utility lines. So
the question is, can we differentiate what the requirements or the responsibilities of either the utility contractor, the utility company, or the electrical contractor? So on most sites, if it's an underground service, say from a utility pole, the utility company usually has one pole on your property. So if you have, so they would expect you to do is standpipe that pole with your conduit, 4-inch conduit plus the spare, and that primary service would be run by the electrical contractor, the conduits, and go to the primary side of a transformer. The transformer pad is the responsibility of the civil contractor or the general contractor. So that's usually put in place for the electrical contractor. In most cases with Eversource, PES, N-Star, and so on, the primary conductors are pulled by the utility company. They make the splice, the utility company makes the splices on the pole with the transformer at the high voltage lines, and they make the connections on the primary side of the transformer. The electrical contractor will run the secondary service from the secondary side of the transformer into the building. So they'll purchase and pull those conductors, and they will make those splices and so on. So that's basically the utility company. In most cases, they'll create a cost for that service, and it's based on the kind of usage you're going to have and what it costs them to bring the service to you. So there's usually a fee that's paid to the utility company by the owner of the building, or the general contractor may carry those costs. So that kind of differentiates, with the responsibility. Utility company provides the transformer, so and that's part of that back charge and so on. So they'll come after inspecting the pad, and they'll come and set the transformer, and then we pull the conductors and we make the connections to that. Yes.
How about the metering?
Well, once we get inside, and I think we'll talk to that, but the metering, if it's a switchboard, there's a metering compartment inside the switchboard. Depending on the voltage of the service, there's a current transformer section of the switchboard, and Will's going to talk about that in the next section here. So you have to, utility company has a metering department, so they have to come out, they give you the requirements, what they're looking for, the size of the conduit to the meter location, and they'll bring what's called the current transformers, which feed the meter. So you have 480 volts, and then the transformer takes it down to a voltage that the meter can accept and read. So that's, now, and one of the drawings that Will has of one of the residential units, we may have, the project we just finished in Cambridge is 370 residential meters. So that's trying to get the utility company out there to set those meters and so on and activate is a challenge, but it's just something you have to deal with and coordinate ahead of time.